Hey guys! So in this video I'm going to be going over the energy work and power paper that's in your packet. We've already discussed energy, so I'm not going to be spending a whole lot of time on that. Instead, what I'm going to be focusing on is work and power. The one connection I do want to make with energy is that energy and work are so very closely related. They both use the same unit, joules, and they're almost interchangeable. So in a lot of places on this packet, on the back page of this paper, when you're doing your work, if it asks you for energy, you can just go ahead and use the work formula. Or if it asks you, you've used this much energy, you can just kind of think of that as work. And I'll go through a few of those problems with you to hopefully help that to be less confusing. So let's do a sample problem here. And this is the third time I've tried to do this video, so I left my sample problem up there, but we'll go through it together anyway. Okay, let's say that I use 3 newtons of force to move this box 4 meters. My formula is work equals force times distance. My force, oh, that's the wrong marker. Okay, my force is 3 newtons. My distance is 4 meters. So my work is 3 times 4 equals 12 joules of work. Or you might see a problem that asks you how much energy did it take to move the box, and that would be the same calculation. You would get 12 joules. Remember, we measure energy in joules. I do want to point something out though, okay? Let's say that I pushed on something really heavy, or maybe I was really weak, I don't know. And let's say that it didn't move at all. Let's say that I moved 0 meters. So in that case, my force, I'm still pushing on the box with 3 newtons. My distance was 0 meters. So my work equals 3 times 0. My work is 0 joules. And what this illustrates to you is that something has to move in order for work to be done. I can move this paper towel back and forth or up or something like that, and I'm doing some work. Not a whole lot, because it doesn't take a lot of force to move a paper towel, but I did move it. But if I push down on this easel as hard as I can all day long, I'm not going to move it any distance at all. So no matter how hard I push, if it doesn't move, I haven't done any work. And that's going to be an important concept on the back of your paper. Let's move over here and let's talk about power. Power is a measurement of how quickly you can do work. The formula is power equals work divided by time, and the unit of power is watts. So let's say that I push a 1,000 kilogram car. Let's say that I push it for 10 meters, okay? Let's say that the amount of work that took was 10,000 joules of work, okay? And let's say that it took me 10 seconds to push that car that distance. How much power is in this situation? Power equals work over time. My work is 10,000 joules. I'll recopy that. My time is 10 seconds. So my power is 10,000 divided by 10 equals 1,000 watts of power. Well, I'm not the world's strongest person, so let's say we had someone stronger pushing the car. Let's say that we had someone like Dwayne "The Rock" Johnson, okay? He's a lot bigger than I am. He's a lot stronger than I am. He can probably push this car a lot faster. So let's say that he pushed this same car. It's the same weight, which is a force, and he's moving at the same distance, so we're both doing the same work. So again, let's say that he did 10,000 joules of work, but let's say that he did it in half the time. It only took him 5 seconds to push the car the same distance. Well, power equals 10,000 divided by 5, and it's going to turn out that he generated 2,000 watts of power, and I only did 1,000 watts of power. He did it in half the time. so he was twice as powerful. And that's just a real quick basic rundown of how to do work problems and power problems. If you look on your formula sheet, you should have these two formula triangles here just to help you figure out. I went through how to calculate work. You might need to calculate force, or you might need to calculate distance. Just like we've done before, if you need to calculate force, cover up the F and you find out that force is work divided by distance. If you need to calculate distance, you cover up the D and you find out that distance is work divided by force. Same thing goes for the power triangle over here. Like I mentioned, energy and work are the same. If you're given a problem where they ask you how much energy does it take to move something with a certain amount of force over a distance, just go ahead and calculate work and that will give you the amount of energy, or vice versa. There's a problem at the bottom of the page that sets something up and it says, what was the difference in the work to move the object and in the work you do? Well, there's something that fights all movement. And if you guys stop and think about that, that's friction. So I put force into moving something, but not all of that force gets through to the object. Friction steals some of my force. So use that information to help you solve these two things. If you see a problem that says, what was the difference? Remember that difference always means that you are subtracting, okay? Let me pull up some problems. On the back of the paper, and let's see what problems you guys might need me to work through, okay? These are all pretty standard. Let's take a look at this one. A 60-watt light bulb runs for 5 seconds. How much energy does it use? That's a case where they have given you watts. Watts is the unit for power. They've given you seconds. Seconds is the unit for time. They're asking you for energy, but remember, energy and work are basically the same thing. So where that says energy, just calculate work, and that's going to give you the correct answer there, okay? This right here, calculate this one on the same object in the previous question. You have to push with 15 newtons to move it 10 meters. How much work do you do? Calculate that out. And then this is that problem I was just talking to you about. What was the difference? You're going to subtract. Why was there a difference? Stop and think about that thing that always fights motion. Okay? You use 35 joules of energy to move a 7 Newton object. How far did you move it? They are giving you a force, and they are giving you energy. They want you to calculate distance. Take that energy and just call it work. So you have work and you have force, and you need to find distance. If you think about your formula triangle, you guys can figure that one out. I'm sure you'll do fine, but if you have any questions, please text me on Remind. Thanks.